This is lesson 41-3. We're working on tree diagrams. Um, the purpose of the tree diagram is to help you understand a rule that you're going to learn here in just a second. Um, so we're going to start by looking at this. Anson is concerned that playing video games are interfering with his connecting with his friends. He decided every day when he finishes homework, he's going to spin the spinner to decide whether or not he plays games or he tries to connect with his friends. Notice that he's finishing his homework first. The 5 outcomes on the spinner are equally likely. He's decided that if he spins either a 4 or 5, then he will play video games. Otherwise, he will not play video games. So here he plays the game. Here he plays a game. Here he connects with friends. Okay, so what is the probability that Anson will play video games? So the probability that he plays, and I think they used a video, V for video. So I think this is a video, V for video. They're going to use this problem several more times. And then the F stands for friends. So we know how to do probabilities. We put the desired event on top. How many desired outcomes will give us video? There's 2 videos on the spinner. And what's the total number in the sample space? There is a total of 5. It says write your answer as a decimal. I'm using probability notation. The probability that he's going to play a video game, his chances are there's 2 outcomes that favor video, 5 total outcomes. So 2 out of 5, I believe, is 0.4. Okay, so now we're going to go over here and we're going to talk about a tree diagram. So the first thing that you notice right here is that they drew 2 lines right here. One to represent that he landed on the option where he played videos. So remember, we have that spinner over here. So if he did, this was the probability of playing a video game. That was 2 out of 5, remember? That's where we got the 0.4. So that's what this represents, playing videos. Well, if you didn't land on a 4 out of 5, then that means he landed on a 1, 2, or 3, and that means he did not. Now remember, this notation right here is for the complement of. And this VC means not played video games. That C right there is the complement of playing video games. The complement is just putting the word not. So this is played videos. This is not played videos. So the probability of not playing videos, now you have to think about, go back to the spinner, okay? The spinner had 5. And 1, 2, 3, 4, 5. These 2 right here were the 2 that we talked about right here. So if he lands on a 1, 2, or 3, what's the probability that that's going to happen? Well, that's 3 places that he can land out of a total of 5. And you divide 3 out of 5 and you get 0.6, 0.6. Now, the thing that I want you to recognize is that these 2 right here add together to be 1, and that's how you know that you've calculated these 2 correctly. These 2 outcomes, the sum of the 2 outcomes, should be 1, because those are the only 2 things that could happen. He's either going to play video games or he's not going to play video games. Okay, then it says Anson found that if once he's decided that he played video games, the probability that he will connect with his friends is 0.3. So they put over here 0.3. Now, what I want you to understand is that this is the probability that he's going to connect with his friends, but it's not independent of this. This only happens after this decision. So it's the probability that he is going to connect with his friends, given that he's already played video games. Okay, that's the 0.3 that we have right there. So this is the outcome for the fact that he connected with friends, given that he played video games. So if you remember that the two outcomes, so after he plays video games, the probability that he's going to connect with friends is 0.3. So the probability that he's not going to connect with friends is, what else do I need? These two have to add together right here to be what? They have to add together to be 1. So what does this have to be? 0.7. And this is given information. I didn't calculate it from the spinner. It was provided. It was given information. You will have to be given this information. All right, same way with this one. If he does not play video games, then the probability that he's going to connect with friends. So remember, this is the probability. This right here, this number right here is the probability that he connects with friends. But he had a different given that he did not play video games. So that's equal to 0.9. So this is a conditional probability. The condition that the outcome that he connects with friends, given that he did not play video games. So again, these two right here have to equal 1. So if this is 0.9, then this one right here would need to be 0.1. Okay. So it says, find each probability, write the answer using probability notation, then write the probability in the appropriate place on the tree diagram. So we kind of went out of order. I've already filled in the diagram, but we can still use the diagram now to help us answer these questions. What is the probability? What is the probability that Anson does not play video games? Okay, so we calculated that one already. Not video games. That was this one right here. It was 3 out of 5. We went back to the spinner, and that came out to be 0.6. And then I pointed out that 0.6 and 0.4 added together to be 1. Because those are the only two outcomes from spinning the spinner. If we had a different outcome from spinning the spinner, then we would have another of these things, and then all three of them would have to add up. So the total number of outcomes that you have, the probabilities have to equal 1. So this one says if Anson plays video games, see, this is the given right here. This is your given. Okay, what is the probability? What is it that he will not connect with friends? What is the probability that he will not connect with friends? So not friends, given that he played video games. Okay, so we found that one. That was, we have to go back to the fact that he played video games, so this has to happen first, and then he did not connect with friends. So those two had to add together to be 1, so it was 0.7. And then if Anson doesn't play with video games, okay, this is the given right here, then what's the probability? They're asking me for the probability that he will not connect with friends, so not friends, given that he did not play video games. So this is the part that has to happen. So this is the first branch, and then this is the second branch. So this is the first thing that had to happen. He did not play video games, and then he did not connect with friends. So this outcome right here is the answer to this question. That was 0.1. Okay, and it says, notice that the conditional probability, friends given that he played video games, is a dependent event. That means that this part right here, the outcome of this right here, changes what happens here. Okay, so the fact that this changes this means that these are dependent events. I believe that you've learned the word dependent already. But if not, then you're learning it right now. Dependent, it says 2 events are said to be dependent if the result of the second event is affected by the result of the first. And you can tell this is dependent by the nature of the situation. So we'll do some other examples where we talk about whether it's dependent or independent in just a second. I think it will solidify what this means right here. So just hang on if you're not sure you understand. Okay, so now it says let's throw in some number of days. So he wants to do this for 100 days. So if he does this 100 days, then on how many of those 100 days would you expect Anson to play video games? Well, the probability that he will play video games is 0.4. So what I'm asking is, what is 0.4 of 100? How do you find that out? You take 100 and you multiply it times 0.4. And the answer is 40. So it says write the number in the box above B. So out of those 100 days, when he spun the spinner, 40 of those days he landed on a 4 or a 5, which caused him or allowed him to play video games. Okay, so we did number 3, we filled that in. Number 4 says, on how many days would you expect Anson to play video games and connect with his friends? So write this number above F. Okay, so he's already played the video games, so now the second condition is going in, and we're going to do it the same way. Of those 40 days, how many of those did he actually connect with friends? So what do we want to do? We want to take 40 and we want to multiply it times the probability, okay, that he's connected with this friend. So 40 times 0.3 will give you 12 days. And it says write this number in the box above F. Okay, so we said 40 days times the probability that he's going to connect with friends, which is 0.3. 40 times 0.3 will calculate 12 days that he's going to end up with friends. And of course, we could go and do the other one. If for 12 days out of the 40 he did connect with friends, how many did not connect with friends? We could just multiply this whole table out and get the answers. Now it says, what is the probability of this event in number 4? So they're wanting to know what are the chances of, what's the probability? What they're wanting to know is, what is the probability of 12 days being the outcome? And this is the desired event, okay, for the probability. We want the desired event, the event that we want is the number that goes on top. This is how we've been doing probabilities the whole time. And the total sample space goes on bottom. So the event that we want is that after playing videos, he connects with friends. That came out to be 12 days. So the event that we want is 12 days. And the total number of days in my sample space was 100. So we found out that that comes out to be 12%. Okay, now it says, what 2 probabilities can you multiply in order to find the probability of the event in item 4? I'm reading number 6. What 2 probabilities can you multiply? They're just wanting you to notice that if we had skipped this information right here and we just multiplied 0.4 times 0.3, we would have also gotten 0.12, which is the same thing. So they're wanting us to say right here, What two probabilities can you multiply in order to find the probability of event in item 4? So we could have multiplied 0.3 times 0.4, and I think I wrote them down backwards. The first thing that happened was the 0.4, and then the second thing that happened was the 0.3, and that comes out to be 0.12. Oh, I put the answer in the wrong place. This goes down here on number 6. 0.4 times 0.3, and that equals 0.12. Okay, I'm going to go ahead and finish number 7, and actually, no, I'm going to stop the video here. I'll do number 7 and number 8 on the next video, and that will get you to the check your understanding. I don't want the videos to get too long.